Good day, viewers. My name is Audrey Polton. Welcome to the second lesson for Grade 9 Physical Science. The lesson topic for today is about forces and work. Let's have a look at the lesson objectives. By the end of today's lesson, you should be able to recall forces in everyday life and that force is measured in Newton. Differentiate between mass and weight. Calculate the weight of an object. Calculate the amount of work done when moving objects over a distance. Now that you have seen the lesson objectives, let's start with the lesson. We can describe a force as a push or a pull. A force is not something that an object contains or has in it. A force is exerted on one object by another. There are many examples of forces in our everyday lives. For example, weight, that is the pull of gravity on an object. The force of a bat on the ball. The force of the hairbrush on hair when it's being brushed. The unit of a force is Newton, and it's abbreviated as capital letter N, and it is named after the greatest physicist ever, Isaac Newton. Now let's discuss the difference between mass and weight. Mass is the amount of matter an object has. Weight is the force exerted on a mass called gravity. Mass is a scalar quantity, meaning it has no direction. Weight is a vector quantity having direction. Mass can be determined by a scale, while weight is determined by a spring balance. The SI unit of mass is kilogram, and that of weight is Newton. Let's now look at how we can calculate weight. The weight of an object is calculated by multiplying the mass with the gravitational field strength, which is indicated as a small letter g. Weight is equal to mass times gravitational field strength. And if we have it in symbols, it is W is equal to mg. Since the weight is a force, its SI unit is the Newton. So G on Earth is 10 Newton per kilogram. Here is one example of the calculation of weight. If a car has a mass of 2000 kilograms, what is its weight? We use the formula W equals mg, and it's equal to 2000 kilograms times 10 Newton per kilogram, and that is equal to 20,000 newtons. Let's now discuss the term work. What is the meaning of the term work in science, and how does one calculate it? For work in the scientific sense to be done, a force must be exerted, and there must be motion or displacement in the direction of the force. When we kick a football, we are exerting an external force, and it is indicated as capital letter F. And due to this force of kicking, the ball moves a certain distance in the direction of the force. This disposition of the ball from position A to position B is known as displacement, indicated as a small letter d. This work is said to be done and can be calculated as W equals F times d. Work is equal to force times distance, and that is equal to F times d. The unit of work is joules, indicated as a capital letter J. An example of calculation of work is an object is horizontally dragged across the surface by 100 Newton force acting parallel to the surface. Find out the amount of work done by the force in moving the object through a distance of 8 meters. The formula for work is F times D. When we substitute the values of the force and the distance, it is 100 newtons times 8 meters, which gives 800 joules. We have come to the end of lesson 2. Let's have a look at the lesson summary. We can describe a force as a push or a pull. The unit of force is Newton and it's abbreviated as capital letter N. Mass is the amount of matter an object has, while weight is the force exerted on a mass called gravity. Mass is a scalar quantity, meaning it has no direction. Weight is a vector quantity having direction. Mass can be determined by a scale, while weight is determined by a spring balance. The SI unit of mass is kilogram and that of weight is Newton. The weight of an object is calculated as the mass times the acceleration of gravity. That is W equals mg. For work to be done, a force must be exerted and there must be motion or displacement in the direction of the force. Work can be calculated with W is equal to F times D. The unit of work is joules. We have come to the end of this lesson. Goodbye until next time.